Fellow colleagues, I am going to introduce you to the concept of propensity score matching methods as a means to control confounding in observational studies. My name is Frederick Morpho and I'm a PhD student in health research methodology at McMaster University. My supervisor is Professor Lehana Tabani of McMaster University, and this video was done under his supervision. Clinicians and policymakers are always searching for the best possible evidence in order to inform clinical and policy decisions. Randomized controlled trials or RCTs rank as a gold standard in the evidence pyramid above observational studies. This is because RCTs are able to minimize bias due to their design, which involves randomization, blinding, allocation concealment, and intention to treat analysis. The critical strength of RCTs over observational studies lies in randomization, which helps to control for both known and unknown confounding factors. This makes treated and untreated groups comparable in terms of observed and unobserved baseline factors. Consequently, observed treatment effects are very much likely to be due to the intervention. On the contrary, in observational studies, treatment groups are likely to differ in terms of baseline characteristics. These differences are likely to confuse or obscure the causal relationship between the intervention and any outcome of interest. This explains why researchers are cautious in interpreting and applying the results of observational studies, because they may be showing what is not there or hiding what is actually there. In other words, they may produce biased estimates of treatment effects. With that said, should we even be using observational studies to estimate the effects of treatment on outcomes? Maybe we should, because we may not always be able to conduct RCTs to inform clinical decisions, as this may actually be too expensive or unethical to conduct in certain cases, while in other cases they may not just be feasible. Moreover, shouldn't we try to explore the real-world settings data that observational studies provide rather than the potentially artificial settings data from RCTs which may not have real-world applications? If we agree we should, then we should strive to make observational studies better. We may not be able to completely eliminate their biases, but we could minimize these as much as possible. One potential and powerful way of doing so, which has gained popularity in recent times, is the propensity score matching methods. But what is the propensity score method? Propensity score is defined by Rosenbaum and Robin as the probability of treatment assignment conditional on observed baseline covariates. Simply put, the propensity score is a balancing score which helps to balance baseline covariates between the treated and untreated subjects in observational studies, such that groups are similar enough for direct comparisons. When we apply the propensity score method to observational studies, it helps to remove the effect of confounding when estimating any treatment effects. Consequently, we can directly compare outcomes in patients with similar propensity scores, which in fact implies we are actually comparing outcomes in patients with similar distribution of baseline features. You may ask, what is the advantage of doing so? Well, the propensity score method allows us to design and analyze an observational study so that it mimics some of the particular characteristics of a randomized control trial. If we can achieve this, that is, hypothetically conducting an RCT without incurring all the costs and hassles of doing an RCT, we may actually be gaining in efficiency, and our evidence may go up a step in the evidence pyramid we talked about earlier on. In order to correctly conduct a propensity score matching analysis, we need to first estimate the propensity score. This can be done using standard statistical packages such as R and Stata. Then you will need to assess whether you have achieved balance between the treated and untreated subjects. This is commonly done by comparing the standardized mean differences between the two groups before and after matching. Once we are satisfied with the balance, we can then compare outcomes using different propensity score analysis methods. The four commonly used analysis methods for propensity score include matching on the propensity score, which is commonly done by using conditional logistic regression on the matched pairs. Secondly, we can do stratification on the matched pairs. Thirdly, we can do inverse probability of treatment weighting using the propensity score. And finally, we can do covariate adjustment using the propensity score. The statistical details in conducting all of this is beyond the scope of this presentation, but for those who are interested, I will kindly refer you to the article by Peter Austin referenced at the end of this presentation. Our interest in propensity score stems from the work we have done on the use of misoprostol in the prevention of postpartum hemorrhage, which is currently undergoing peer review. Kindly look it up once it is published in the near future. We thank you for your kind attention, and if you have any questions, please kindly address them to us at morphoeth@mcmaster.ca.